Well, I was hoping for another person to show up who's going to take notes, but that will happen as it happens. I know I'm speaking very softly, and this thing seems loud to me. Can you guys hear okay? Yeehaw. Huh? Excellent. Well, this is the chat about Network Time Foundations and its projects and status updates. I'm going to begin by feeling a bit sad because Dave Mills died a short while ago, and I'm still very glad I was able to learn from him and work closely with him for the past 30 years' time. And it's regrettable that we weren't able to do even more together. A friend of mine sent this to me, and so we called the XKCD guy who does this and said, hey, is it all right if we use this? And he said, yes, use attribution. So down over there is the attribution. Let's see if my mouse will do. No, my mouse will not inflict upon you. So that's there. This slide tells a bit about how Network Time Foundation came to be, and I'm not going to say more about it because it's hopefully in the online presentation slides, and you can look if you feel like it. Most people are at least aware of NTP. The LinuxPTP project's goal is to be the best performing PTP software under the most recent Linux kernel. The libptp management project is a type length value management library that also has some monitoring capabilities for LinuxPTP in particular and other PTP things as they respond to the management TLVs. We're spinning up 3 SyncE projects, and NTF is neutral, and the 3 companies that are working on open source SyncE projects under NTF's umbrella are happy to play nice with each other. The Khronos project's goal is the delivery of ongoing provable bounded time limits to prevent time shifting attacks. Margaret, come over here. Feel free to come up here if you want. Okay, sit where you like. I'm in charge, you can do what you want. So I want to talk about Khronos first because it affects NTP and PTP. The folks who are working on Khronos have good ideas on what the threats are, how to detect them, and how to mitigate them. Other folks are concerned that some of the proposed detection and mitigation plans are unworkable because they may impose a heavy network load or a heavy load on the target systems. But we're confident we can come up with solutions that'll work for everybody who's involved in it. Okay, doing it this way. That RFC 9523, that was just announced in the last week or two. So NTP 428P18 is due out soon. I was hoping it would be out before now, but I wasn't expecting Dave to die and my laptop to die just before this, and things keep getting pushed out a little bit more. P18 is going to fix between 2 and 3 dozen bugs, and the NTP TCP services effort is partially funded by a 2023 Aaron Community Grant, for which we are very grateful. We're actively identifying DDoS and abuse vectors involving NTP, and as it says, we're looking for funding and beta partners to help us get this implemented and get this workable and disseminated. Looking forward to sharing our results on that as it gets underway. So the LinuxPTP project, what happened to my notes? Too bad. The LinuxPTP project, as you can see, is up here. It keeps growing and getting better, and the release that was scheduled for early March is now going to happen later in March or possibly in April because there have been a flurry of patches around the authentication of TLVs and other things, and those changes are extensive enough that Richard Cochran is waiting for the paint to dry before he blesses it with a version number. The libptp management project was originally designed to support monitoring and statistics of LinuxPTP, but any device that responds to the standard PTP management TLVs can be queried by it, and we're very interested in extending libptp management to include, to make sure it works well with any PTP device that understands those management TLVs. He's going to be updating that with the new stuff that, shortly after Richard announces the next release of LinuxPTP. The SyncE projects are coming on board and ramping up right now. There's going to be more information on the website soon. That's my way of saying, I asked all the folks if they had stuff they wanted me to say here, and crickets, which is probably better than cicadas, which will be coming up later this season. But I'm glad that we've got 3 companies who want to open source their SyncE efforts. Each one of them thinks they're doing things the better way. And the nice thing about having them under an umbrella here is they're going to be talking more to each other than they might otherwise. And I think that's going to be a clear case where the rising tide floats all boats. So these are other things that we're going for. We get no government funding. The bulk of our funds come from our institutional members, and individual memberships and donations help out a lot. We use our funds to continue to improve and evolve all of our projects' security, support services, and documentation. And we hope that the more you learn about NTF, the more you'll understand and appreciate the work that we do. And guess how that appreciation can be expressed? Anyway, the global community, user community, relies on our technology pretty much every minute of every day. So we invite everybody to follow us, share and submit posts that they think are of interest to the community. Since I covered all that stuff in just under 10 minutes, well, probably under 5-ish, we're going to go to something slightly more fun. Margaret likes to, this is Ruthie, one of the foster rescue kittens we've got, and the kittens like to hang out on my rack because it's nice and warm, and sadly they don't care that the fan noise is kind of loud. Margaret likes to joke that we use Cat5 cables. I got asked a question a lot while I was here, 3 times as a lot, about how does NTP work. So I figured before I start going for questions, I'd show a slide. If a client wants to know what time it is, it asks the server. And so the T1 timestamp is what time the client asked for it. T2 is the time the server gets it. T3 is the time the server sends its response. And T2 and T3 are usually very close together. And T4 is the time that it gets back to the client. And so from this you can see that if you subtract T2 from T3, you're going to get the overhead time for the server to get and process the response. The total round trip time is going to be T4 minus T1, and then you subtract out the overhead time. So the one-way time on a symmetric link is going to be RTT over 2. Kind of easy. So if the client and server are synced, T3 plus half the round trip time is going to equal T4. And with a single volley, you can set your clock. If you send a volley, wait, and then send another, you can see that your clock is running faster, slower, or at the same rate as the other guy. And then you can calculate the rate of difference. Probably. Because you don't know whether or not the remote clock changed its time in the interim or if somebody changed your clock in the interim. But overall, this is how it works, and it's kind of simple, and the devil is in the details. So to conclude the prepared notes for this discussion, that's where you can find us. If you want to help us out in any way, please let us know. We've got join and donate links, and if you've got any questions, please email them to info@. And that looks like it's all we got. So we're open for discussion. Yes, sir. your comment was, as you get multiple servers in there, NTP is going to calculate the rate and sanity, which would be jitter, dispersion, noise, how well it tracks time, and NTP can use that to decide who to throw out and who to keep listening to, and that's exactly right. And that's why it is really important to have enough servers when you're doing an upstream. And there are a whole lot of people who are concerned that if they have more than a couple, they're placing an undue burden on the servers. And I will point out that a small packet, excuse me, sent once a minute when you're starting up is not a heavy burden when you got people downloading movies or playing real-time games. And as NTP ramps up, excuse me, as NTP ramps up, that's going to go to once every 10 minutes or so. The pool directive in the NTP config file will spin up 10 associations upstream. And every poll interval, it ranks how good those are. And if any of them fall off the edge or start to look bad, it throws out the poor performing ones and resolicits to get new servers. So most people know that 1 is dangerous because if it goes away, you've got nothing. 2 is not a great idea because if they ever disagree, NTP won't know which one to follow. And one of the few benefits I've seen of deciding that leap seconds aren't useful is that there were cases in the past where somebody would have 2 servers, and they would then discover that one server was presenting leap smear time and the other wasn't. And so as the leap steer started to happen, they steered off in different directions, and pretty soon the client became unsynced because it couldn't find a common time to follow. One of these folks did this 2 leap seconds ago and said, we're going to solve this problem, we're going to use 4. And when the next leap second came around, they discovered 2 of them followed regular time and 2 of them followed leap smear time, and they both sailed off, and NTP went, I don't know who to believe. So the answer in general is have enough sources of time and monitor them so you can see what's going on. So did that pretty much answer your question? With any luck, somebody else has a question or wants to hear about something. Yes, ma'am.
How do you do the verification part? Like, do you just, like, how is T2 and T3 verified in a sense?
Ooh, somebody, yay.
Hello, hello, hello. How does the verification layer of it work?
There are several verification layers.
Okay.
There are, great question, thank you. For starters, I'm going to call it the receive code because it's in IO receive, which is one of the functions that comes in and reads the packet, and that goes through a lot of sanity checks, and we make sure that T2 isn't greater than T3, and if it's too long, even if we don't throw it out immediately, it'll get thrown out later on because it's in a strange value. But we do fairly stringent checks on the data that come into the packet, and it isn't until those all pass that we'll decide to use it. And once that's the case, it goes into a buffer of the most recent 8 polls. And we throw away the outliers, and if there are multiple sources of time, we'll decide if a particular source is in the clique of valid servers or not. And so we're pretty good about that. Another aspect of that is authenticated time. So right now there are several ways to authenticate time. One is with private keys, and then there are currently 2 ephemeral key mechanisms. One is ancient auto key that nobody should be using, and people are still using it, primarily because, I'm told, because some of the auto key methods will do things like exchange the difference between TAI and UTC, so they get a leap second count. There are other ways to get that information now, but these folks appear to be saying, if it ain't broke, don't fix it, and they're running this inside networks where they aren't worried about the security vulnerabilities of auto key. The other problem is just because a packet is authenticated doesn't mean it's true. It means it's authenticated. And so while you're going to weed out a percentage of bad behavior by using authenticated time, that doesn't mean your answers are any better. As I mentioned in an earlier slide, we're working on a TCP services daemon that's going to be in the NTP 4.4 release. That's going to be our NTS key exchange server, and it's also going to serve ephemeral keys for our alternative ephemeral key mechanism that we're currently calling secure network time. I mean, if you can't play with the order of the letters, you know, how much fun can it possibly be? So getting that level of authentication is nice because, as I said, it prevents a slew of attacks, man in the middle, some of the other things. But it isn't the same as having high quality time, and the good news about saving 8 of the most recent exchanges with someone is you get to see what their behavior history is like. And you couple that with Khronos, which I think I didn't talk enough about. Khronos is designed to give provable bounds on time. And once it's been operating, it's apparently good for at least 200 milliseconds, plus or minus. And we're going to see how good it does in reality. But what that means is if a bad guy wants to come in and start steering your clock, and they start to give you time, if they give you time that's outside of Khronos's bounds, drop it right away. And that helps a whole lot too. So it's a complex problem that has good news and bad news at many different layers, and the trick is making sure pay attention and you monitor things and you see. There was default behavior in the code that would detect problems. So if I'm talking to a server and they send me a kiss of death, back off because your rate's too fast, that may not be true, but that's what they're telling you. And the next question is, how can you authenticate those? Because it could be that somebody's trying to do a denial of service. There are situations where if you detect a problem, you want to act on it quickly. But there are other situations where if you act on it quickly, that becomes a denial of service attack. And likewise, if you act on it slowly, there may be problems because somebody's starting to move your clock in a direction it isn't supposed to be. So I have tended to see a number of cases where people will fixate on a particular problem and make sure that we take steps to avoid that problem potentially at all costs. And I will say, yeah, but if I do that, I'm creating the other direction, we're creating a different denial of service attack. So from my point of view, the way to go there is to make sure that NTP has a sufficient number of mechanism choices so you can then implement your local policy. If you see an attack coming in that's causing you to do denial of service, you throw it the other direction. If you see that somebody's doing something, you make it happen sooner. And you can make these choices as the need arises in the actual event. Was that at all a useful answer? Very useful. Yeehaw. With luck, maybe somebody else has a question. Yes, yay.
Harlan, I just wanted to gauge your opinion on the alternative NTP projects out there. I know there's 3 that I know of. There's Khronos for the Linux systems. OpenBSD has OpenNTPD. There's NTP-sec written by ESR, which I don't think anybody uses, but I know with OpenBSD, they have less precision, I guess because of simple code, but with Chrony, I think it's kind of a mix between PTP and NTP because it has PTP-like precision, if I'm not mistaken, and I know a lot of the distros are using it. Does the Khronos project answer any of those kind of alternative projects stances on security, things like that, or?
So your question is about NTP from the NTP project versus Chrony from Red Hat versus NTPsec versus OpenNTP from OpenBSD. I'm pausing because I want to speak appropriately, and this is a recorded session. Chrony doesn't use our algorithms. And Miroslav did a lot of discussion about this on the mailing list and their discussion with Dave's. NTP selects a cluster of the best performing servers it can find, and it steers to the middle of that time. Chrony, as I understand it, and Miroslav has told me he agrees with this, assuming I'm still phrasing it correctly, Chrony evaluates servers, finds the server it thinks has the best idea of time, and steers toward it as quickly as possible until it sees that there's another server it thinks is better and steers to that server as quickly as possible. OpenBSD did their OpenNTP because they were really pissed off at our license. There was a line in this license that says, you can do all these things and, without fee. And they weren't sure if that was a conjunctive and or the other type of and. And so they weren't sure if that meant they could do these things and there wasn't charge, or you can do these things and you can't charge anything to get a copy of it. Dave Mills had zero tolerance for discussions around licensing and stuff like that. So when this happened, Dave basically told them to pound sand when they wanted to get, to do those things. And so they went ahead and implemented OpenNTP. And let's just say, for a number of years, I was probably publicly, I was not happy because they made some mistakes that were just unbelievable. But, it's their rules. Their product, their rules. So that's there. As far as NTPsec goes, that was a hostile fork, and there was a whole bunch of stuff around there that I'm not going to go into in a public forum, but I will lower myself enough to say NTPsec implemented NTS because a lot of the people who were on the NTPsec project were the original designers of the NTS ephemeral keying model. And I had a bunch of vendors say, we really need NTS, and I say, we really want to give it to you, and I have no resources to pay anybody or volunteers to do it. And if you feel like switching to NTPsec, go with my blessing. I strongly recommend you do your due diligence first. And let's just say, to the best of my knowledge, we didn't lose any institutional members over it, and none of them switched to NTPsec. So there's that. As to whether, you mentioned whether or not Chrony might be able to be more precise than NTP. I'm not sure. Dave Mills thought Miroslav had an excellent understanding of the core algorithms, and so I expect in that regard it's probably excellent and wonderful. My more general concern is that the unstated goal of NTP is that NTP have a, what was the word Dave used? has a known and predictable response to a time impulse. So if you're chugging along and you've got a bunch of people behind you and suddenly the time steps, how do you behave as you get toward that new time? And Dave was concerned that he didn't see, and I don't mean that literally because Dave was effectively blind by then. But he said no one had done the work to prove, he had not seen that anybody had done the work to prove that Khronos algorithms would be stable in the number of scenarios that Dave had proven that NTP is stable under. So this also goes to people want to separate, many people want to separate the protocol from the algorithms in the standard. And Dave fought that tooth and nail. And the biggest reason for that is if you just follow the standard and you don't follow the algorithms, you may not get good impulse response yourself. And what's worse, if you implement it that way and people are following you who use different algorithms, wheels fly off the bus and everything falls apart. So no one has yet offered to commit to the level of work it would take to define what that behavior should be. And if we did that, it would allow us to have different algorithms in there, which would be great, but no one's stepping up to do that work yet. With that in mind, one of the other projects we'd love to be working on is Paul Henningkamp's NTimeD effort. He threw out the algorithms and did the testing and did his clock selection using probability domain functions. And so he's in the Netherlands, yes? Or, yeah, Denmark. Okay, sorry. I apologize to people for my poor sense of geography. With the PDFs, if you're dealing with a bunch of close machines, you can get a slope like this of deciding who to believe. He tested NTP servers around the world and found one in New Zealand that was the farthest away network path of anything. And for that machine, the PDF filter was out like this. And he compared a bunch of different servers using NTP algorithms and his PDF stuff, and he decided his version was doing actually a better job at finding correct time than ours. And that's something I would love to go ahead and work on if we had the resources to do it. So he also wanted NTimeD to be a very lightweight client. And it's a few thousand lines of code right now. And that's great. It has no management, it has no monitoring, it does no authentication. So we're going to be, as soon as we can, we'll be taking his code and adding those things into it. It's going to be bigger, but there's value there. So did that sort of answer your question? Cool. With luck, somebody else has other questions or topics they'd like to discuss. I can't hear you.
I'll add one on to that. Is that working now? Okay.
I'm sorry.
Do you have any thoughts about the public cloud providers, and as more and more people are running on a few very large cloud providers, does that have any effects because you have the cloud providers making their own internal choices about time infrastructure, and they could be putting their finger on the scale unintentionally or intentionally with some of these choices?
The question was about, do I have any thoughts about the increasing number of large providers who are providing their own time and how that may or may not be affecting others? They're free to, on the one hand, it increases the level of danger and it shifts a little bit of responsibility to the user. One of the things I didn't mention about the issues of separating the algorithms from the protocol at the standard level is there are people who write specs saying, under contract, we expect you to match the behavior of NTP version 4, RFC, whatever. And that's good news, bad news. The good news is they're getting that as a complete package that has known behavior patterns that they're gonna get because of the way it was implemented. If one separates the behavior from the protocol, you suddenly have no idea how it's going to behave, and the people who are going to have to make that decision don't even know that's an issue they got to worry about. So it cost shifts that level of knowledge and care to a group of folks who don't even know they need to worry about it. It's like, it's not a great analogy to say, it's sort of like buying a car from IKEA instead of buying an assembled vehicle from somebody that's run it through crash testing and safety and a whole bunch of other fun things. The other side of it is, for years, I'm not picking on Google. They said they wanted to run leap smeared time, but they would never offer leap smeared time to the public. One day they did, and that caused a bunch of trouble. And there are other, but it didn't cause trouble for them, but it's their time. So we've got some proposals that we'll be implementing that'll come out in 4.4, and I'll set them up I'll submit them to the IETF working group that will let you identify. If you use it, it'll identify you as a server that's providing leap smeared time. And folks just got to be careful. The other side of that is, if you want legally traceable time, you got to use NIST, or whoever time source you use must be traceable to NIST, because NIST is the final arbiter, is the legal final arbiter of commercial time in the United States, at least. Interesting side comment, I did not realize that the FAA does not get their time from NIST. The FAA gets their time from U.S. Naval Observatory, because under times of, I don't want to say war, but you get the idea, the FAA, the Air Force takes over the airspace control, and that means they take control over the FAA, and they don't take control of the FAA, they take control over the airspace, which means FAA has to get their time from U.S. Naval Observatory, because that's where the military gets their time from. So, did that sort of answer your question? Okay. With luck, somebody has another question, because, you know, we still have 25 minutes. I might invent some things to talk about, but.
Sorry, I don't mean to monopolize the questions, but is it okay to ask you a question about the NTP pool? Is that appropriate?
No, but yes.
Okay. This may have changed now, but a little bit after the pool opened up, you could join the pool, and they had little knobs where you could kind of set how much traffic you wanted.
Yes.
That was totally wrong, because I said I only wanted whatever kilobytes or megabytes per second or whatever it was, and it just totally ate up my bandwidth, and I turned it off.
Yeah.
And then I was
Well,
still
you
getting
said
traffic.
to turn it off. I bet you it didn't go away for a long time.
As I was about to say, it didn't go away for a couple of weeks or months. Is it better now? Because it was, I think, a year or two after the pool was set up. So I don't know if they've kind of tightened it and it's better controlled now.
So the question was about the pool project and whether or not things are better now regarding bandwidth limits and usage. Is that about it? Okay. The short answer is the pool project is outside the scope of Network Time Foundation, and the pool project uses pool.ntp.org because Ask, Bjorn Hansen, and the predecessor whose name is escaping me, the joys of getting older, I said, sure, this is a good thing, let's do it. So while there is association with the pool because they're using the ntp.org domain, there is no control, and Ask has better things to do than, Ask has well-defined areas that he wants to focus on. And I don't believe, there are two problems there, one of which is that some people will go ahead and use the pool to get IPs, and then they'll use them forever. and the other is related to that, and I just forgot what it was. But the next release of NTP, 4.4 at least, is going to put in code that will rescan the pool. So if people upgrade the code, and we're expecting to have enough bug fix, the bug fixes are probably not going to be a huge deal, but the functional improvements we're making, we think will be a compelling reason for people to update. That will solve the problem because we're not going to keep people's IP addresses in there forever. That's a nasty problem that several people have tried to fix. Several different people have each sequentially tried to fix that problem over the years and failed, and when I call them about it to ask if they're interested, they say, no, I'm not going near that again, but you have my best wishes if you want to give it another try. And it goes to, should the DNS TTL be used to tell you when you should relook up the IP address again? And the answer is probably not, but it's better than nothing, because there's some folks who are going to set their TTL to something short because they're using cloud or something else, and you don't want to force NTP folks to be redoing a DNS lookup every single time. So we need to find a way to tell people what the maximum lifetime is of an IP that they get for that. And the good news is I spent several years doing, with the NTP project hosted at ISC. And so I know a bunch of DNS wizards. And the question is, where can we find enough virtual cups of coffee that we can talk about these issues and try and deal with it? The issue of bandwidth is nasty, and it may also be that now I gotta wonder if you can fix that with kiss of death or something, except that requires the receiving software to actually do something about it. And it's an interesting issue, and if it's something you want to talk about, please send me email, and we'll make sure you're on a list where we chat about these things. Was that a sufficient answer to your question? Cool. Are we done, or should I babble about stuff? I mean, we've got 20 whole minutes. Huh? Babble about what? The first project that came, one of the first projects that came after NTP was PTPD. And moments later, I got in touch with Richard Cochran at LinuxPTP to see if he wanted to join too, and he said he was happy to do that. You may have noticed, if you've been to Richard's website for LinuxPTP, he writes websites about as well as I do. And now that I've got people who do websites for a living and actually know how to make it not look boring, the websites are in much better shape than they used to be. So Richard came on board. That was great. A couple years later, the PTPD folks decided they didn't want to be part of NTF anymore, and they wanted to go off on their own, and they did. It is not clear to, I haven't seen much happen on that project since then. I don't know if, I don't think that's related to the fact that they left NTF, but LinuxPTP is Linux specific. It uses GPL, and the unsaid portion of the first part is it doesn't run on anything else. It's not going to run on a BSD system. It's not going to run on Windows. PTPD was portable, and it had a Berkeley license on it, which meant it was friendlier for a bunch of constituents. So Richard has no interest in any of that. He wants it to work well under Linux, and I will support him to the best I can to make that happen. So I'm wondering what it will take to support a PTP effort that will run on more places. And as I mentioned at the beginning, Richard has decided that he wants to get updates out every quarter. And he had scheduled a LinuxPTP update for the 5th of this month. And a couple weeks before that, the project got patches for the authentication TLVs. And I probably see a full set of patches go by for that twice a week now, as they're hammering out the last little bits of how should that work, what should and shouldn't it do, how do they make it better, how does it address some of these problems. And they seem to be getting really close to being done. And my understanding is Richard is waiting for the paint on that to dry before he releases this quarter's update of LinuxPTP. There is a LinuxPTP Git repository at NTF. I wish I could remember what the name of it is, but it's going to be on our website. There's also the traditional Git repos available, and they accept pull requests and patches all the time. I have several institutional members who have told us that they're interested in seeing documentation updates because the examples, especially the configuration examples for LinuxPTP, are syntactically comprehensive, but they aren't usable. And they want to make sure they'd like to have a working configuration example for each of the different profiles that are out there, and some discussion about why you might choose one option over another, or one option value over another. And the current answer I have for them is we want to see that too, and until we have enough resources to have somebody do that, patches are welcome. I mean, patches are going to be welcome regardless of whether or not we've got people working on it. But we are very interested in seeing the configuration guides and the rest of that work. And toward that end, we're very interested in monitoring and statistics. I know I want that in a variety of ways for NTP, and it seems like that's a really good thing to have at the enterprise level for PTP. And so I'm working with Erez Giva, the project manager for libptp management, to make sure that happens. And I mentioned this to at least Heiko Gerstung of Meinberg, and he is very interested in seeing libptp management being able to send management TLVs to their ref clocks for monitoring purposes, just because it makes it easier to see what's going on, and somebody can have a unified tool set that monitors all the different PTP devices they've got there. That's what's coming off the top of my head. Is there anything in particular you'd like to see? Anybody else on, have wish list items for LinuxPTP or NTP or anything? Hi.
Hi. So earlier you said something around, I can't remember exactly, but like you said something around local networks or local communities, let's say, having their own like playbooks to run it on their own servers or something in that regard?
I have a vague recollection of saying that, but that was minutes ago.
Yeah, that was a long time ago. So I'm trying to reflect it onto this, like how, so in order, let's say in a scenario where a local network wants to run their own time server.
Yes.
Okay.
They should.
They should, but then is it software specific completely to, like you need to have Linux or another type of software to run this, or?
If you're running the question was, if you've got a local collection of devices that need NTP,
Yeah.
should they run NTP, what I'll call a localized NTP service
Yeah.
that gets time from the outside
From
and
the
then
outside.
disseminates it inside this cluster or group or something?
Exactly. Yes.
I think so, absolutely. And
Okay.
it shouldn't be one device, it should be 2 or 3 or more. And we're looking to make that, we've got some ideas on how to make that real easy for folks. The primary reason is if you have one thing and it goes bad, you're in trouble. If you've got 2 things and one disagrees with the other, you're in trouble. So it's good to have multiples. And this is a case where NTP's peer mechanism works really well, because if I've got an NTP time, a set of time servers that provide time service to the local area, they can peer with each other. And I go to any one machine and I type in NTPQ-P, I get all of those machines and I look at them and I can see the numbers, and life is great. If anybody's misbehaving or isn't answering or is off in the weeds, I can tell right away. Each one of those, in addition to peering with the others, can peer with other devices. And with USB GPS pucks being so affordable, it is feasible to have a bunch of low quality, low cost Stratum 1 servers spread around. And you can take your low quality Stratum 1 server and turn it into a higher quality, high cost server by adding things like a rubidium frequency standard to it. And it depends on whether or not you think, $1,600 is a lot of money, or $1,600 times 4 if you want to have 4 servers like that. So the other aspect there is we have long recommended that if you are going to have that multiple sources of time, that means you don't buy GPS devices or potentially even ref clocks from the same vendor. Because depending on what batch you get on GPS, they may all have the same 1024 week rollover date. And if there's a bug in that, you've just lost, and you bought 10 of them, you now have 10 failures instead of 1. So it's important to have that kind of diversity. There have been a number of bugs in different people's implementations that crop up on magic days for some definition of a magic day. And if everybody's running the same version of firmware and they're from the same manufacturer with the same chip base and something else, and you come upon a magic day, you got a whole bunch of outages. And so there's something to be said, if you're really careful about that, to make sure you have a variety in the mix, if that makes sense. And that's another reason why NTP 4.4, we're going to be putting a lot of effort into monitoring and some statistics stuff, because people will occasionally set these things up, and I know one group had 30,000 clients, and they set their monitoring system up so if they lost a server, they had 30,000 alerts go to their NOC. That costs real money to fix, because you got to slog through 30,000 tickets and say thank you, thank you, thank you, thank you. And that's a lot of thank yous to send out. So if we can come up with a way to improve the monitoring, so instead of generating 30,000 NOC reports when something goes out to generating 1, we've just made somebody's life a whole lot easier and faster. Because the other side of that is you don't have to have a team of people answering bogus NOC tickets or replicated NOC tickets. They can be going out and fixing the problem. So that turns into a win-win. Yeah, I'm trying to think if there's anything else I can answer on that. But was that good enough start? Yeehaw, thank you. Anybody else have anything in the last 7 minutes we have been allotted? I'll try and think of an interesting story, but I may not get there. Not there. Huh? Oh, excellent.
Again, apologies for monopolizing the question. I had an interesting issue a couple of months ago. There was a box that I helped manage, and I noticed the clock was off. And I went in and checked, and it turned out the service provider, after the amplification attacks, had decided to just firewall off port 123. I didn't agree with that, but okay, whatever. So I had to change, and it took me a while to debug it because I think it's NTPQ-D or whatever it is, doesn't use source port 123 to go out.
Yep.
And
It
so I
uses- yeah.
thought everything was working, but then when the daemon was running, it was using 123, which was being blocked.
Yes.
So I didn't catch that for a while. Is there a way to change the port from NTPD? Because I was trying to like do all sorts of kludges to tunnel it and things like that. And what is your opinion on that? Is that something that sysadmin should be able to configure or not?
The question was what to do about the situation where an upstream provider blocks port 123 because of abuse in days gone by.
That and my solution to it was to try and tunnel NTPD to a server that I knew had a good clock.
Yes.
But I found it really hard to tunnel UDP, and I gave up after a couple
Yes.
hours. It wasn't
Yeah,
worth it.
because you can't, I mean, NTP is a UDP-based protocol, and tunneling it is tough because the tunneling process introduces a lot of noise and jitter. Thank you for the question. We got a help request from a company that was having trouble getting NTP to some of their clients on their internal network. And after we dug around, we discovered that their internal network provider was filtering port 123 between the same client in different data centers. And so once they got clue by Ford and removed that, everything magically worked again. It is technically possible to allow people to use a different port than 123. The problem is if you do that, it breaks a whole lot of other things. And I'm open to discussing it. The problem is it would be better to vote with your dollars and then have, if that's a local provider, beat on them and do it. These slides I had back there about DDoS attacks and the rest of it, we're hoping to show them that that problem has been solved. But we've got people saying, well, we want to run NTP on another well-known port. Great, you're not really fixing the problem, you're delaying it, or you're moving it somewhere else, and it's sort of like, I know, we'll shut off this spammer's IP and they won't be able to send spam anymore. Well, they get another IP and they do it anyway. So it's a really interesting problem, and I'm going to drop a name. One of the folks we want to work with is Team Cymru, and they've got monitoring spots all over the world, and there's another group whose name I'm forgetting. We're also dealing with PCH, Packet Clearing House, and we want to make sure we can monitor and catch these things, and there's stuff we know we can do in our code that would fix those things. And as we get NTP 4.4 deployed, I think we can make some real headway there. So, because if you wanted to offer an NTP service, not on port 123, a potential solution to that is to throw a text record into your DNS. And so if you look up the NTP UDP record and it says use this other port, that's great. But we had somebody come to us and say, hi, we're using the pool to provide time for 6 million of our clients. We just realized that costs you money and we're not paying for it. We think that's not good citizenship. We want to pay you for it. So we looked, and I talked to Ask at the pool project, and he said if they want to get the time 3 times a day, 365 days a year, call that 1,000 times a year because it's thumbnail math, and who cares if 333 versus 360. So providing the time for a year at 1,000 packets, he said he could do that he said the cost to provide the time is about 1/3 of a cent a year. The problem is monitoring and DNS on the pool costs 2/3 of a cent a year. So we got to tell these folks that we could do it for them for a penny a year, and I got the education that 1/3 of a cent is what it costs to give them the time, and 2/3 of the cent is the pool system's infrastructure to do quality metrics on the clients, and then get them into the DNS server that takes electricity and cycles and bandwidth to generate the DNS response that says where to go for service. So there's things we can do, but I'm not sure I want to get into the situation where if I get an unsolicited, unauthenticated request for time from somebody, Dave always says it's cheaper to answer them than it is to do anything else about it, because it also cost shifts the problem to the server to make sure you want to answer them. But it may be that we're getting there, and I'm really not sure I want to get into the situation where we're asking people to do a DNS lookup if they've got unsolicited requests coming in to make sure they want to reply to those or not. But we got to come up with something, and that's going to cost money for people. And we have enough trouble with people realizing that NTP has been free for 30 years, and whether or not they should decide to throw a little into the kitty to help cover the expenses. I hope it was not inappropriate for me to have said that. Did I cover your question? Well, we got like 45 seconds if somebody has a really intense question they want to ask. We could knock off early, too. Oh, and thank you all for being here. I really appreciate that. Thanks again.